Okay, so let's see. Last class. This is supposed to be here. Yes. Okay. And if you recall, last class, we discussed, I think this is the second implementation for linked list. And for this case, just a quick review, okay? So it's generic, okay? But this generic type must support the clonable interface. So the clone method must be implemented so that we can support a real deep copy. Okay, so the real deep copy, the idea is for the data part. So this data part, this is the data part. The data part are also going to be in their own memory location. Okay, so these two independent of each other. So for each of it, it's going to be the case. So each one is in its own memory location, okay? This is especially important. This is especially important if data type is reference type. Okay, reference type. This is especially important. And also for this linked list, we also let it implement the iterable interface. So that means within this linked list, you also need to implement that iterator method. And iterator method, what it returns, it returns an iterator type. Okay, iterator type. And this iterator, on the other hand, it's a support that has next and the next method to advance to the next item and to retrieve the next item. Okay, so that's a point here, so that it can support the for each loop. So that's the key point here for this implementation, okay? And we already discussed insert after, remove, contains, get, to string. And I remember we also explained the equals. Okay, the equals here also, be careful, it's compare contents. The contents, okay. So contents then means for each node, you need to compare the contents part. They shouldn't be in the same memory location, okay, but their value part are the same. So same thing for all of the remaining codes, is it? That's why regarding the data part, then you use its equals, okay, using this equals. That's regarding the data part, okay. So that's the equals method. And this one, I believe we also discussed, is it? So this create a deep copy of an existing linked list, okay. But of course, if it's null, your copy should also be null, etc. So it's the return type is a linked list. in order to do this, then you need to do the node by node copy. Is it node by node copy? So that's why over here you call the clone. The clone is regarding the data part. Okay, so here be careful. It's the data parts. It's this part, the data parts. Clone, okay, not the whole linked list clone. Okay, so this is a data parts clone, but then you need to one by one. And at the same time, for the newly one, you also need to connect the we also need to connect all new nodes. Okay. So that's regarding this part and so the last leftover part in this example is about that iterable interface. It's iterator method. Okay, iterator method, we always know it's a return type should be iterator. Okay, and over here we return a concrete object regarding iterator. So what that is? So that is this class. So this is an inner class. Okay. So this iterator class is an inner class. We call it linked list iterator. And it implements that iterator interface. Okay, because it implements the iterator interface, so it needs to override the has next method and the next method and the remove method. Okay, so has next method. So in this case, for this iterator, we also need to define something. So this serves as a cursor, serves like the cursor. Okay. So you have the linked list. Then we have the linked list. So basically, this is the next node. This is the next node. The type is a node. So initially, you initiated to first node. So this is the first node. That and has next is to check if it reaches the end. That's it. So if it's here, then definitely it's the end of the linked list. So that's the end of the linked list. Okay, it doesn't. Otherwise, for each of the nodes, it's not the null value. So it still has next. Okay, if it still has next, what is this next? This next, basically it returns current node's value. Okay, and at the same time, it's also advanced to the next. Okay, so it's first to check if it's already null. If it is not null, if it is not, then you throw the exception. Is it? If it is not, then you need to get its data part. So that's you assign it to this variable, the data part. Okay, then you advance it to the next. So here you advance. So get value first, then advance, then you return that value. Then return that value. Okay, so this is what this next does. And for the remove here, we didn't implement. Okay, we just throw an exception. Okay, so after we implement this iterator method, that's why over here, for this equals, we can do this for each loop. Okay, So this we use for each loop from our linked list. It's because we implement that iterator method. That is because of the iterable interface. That's why you can use it. Okay, if we don't have all of those, then you cannot use it. It won't work. Okay, so that's how. Over here you can also directly. So this colon, because this is the object itself. So basically it's a linked list object. And linked list object is what is in main. Is it when you do like a link list, suppose it's a string, is it? So suppose L, we call it LA, suppose, okay. Then you will do that new link list, is it? We can. So this is that object itself here, whenever you create. Then you do LA dot like equals, maybe LB, is it? Then over here, this refers to this LA, okay? Because this equals belongs to it, okay? For LB, then it's, if you call LB dot equals, then this means LB, okay? So it depends on which object you are referring. But anyway, this means the object itself, because over here, this is just class, that we don't have object, but we still need something to refer the object in case you create an object. So that's why we use this special word called this, okay? And that's why also over here, it works like that, okay? So this is also means the linked list itself, okay? So because we support iterables, and that's why over here you can do for each loop. Otherwise you cannot, okay? So be careful here. And that's the major information for this linked list. Then let's take a look at the application, okay? So over here, in this case, in this example, we also have a car class, okay? So that's why over here, we are going to, so this linked list, the type is a car, okay? So then you just create an empty one in this case, is it? And if you want to add a car, then you need first to create a car, is it? Then you call that insert after. So basically in this node, it's going to have a car, is it? So it's a car within the node, okay? The data part. So you insert after, is it? So this is a car you just created, and its next is a null. So that's why here you put null, because that's the first node. So this is that of a car, so it's default. The default is that that's the first one. And then we insert after another car 1. So then you have car 1. Is it? Then you insert after car 2. Is it? And then car 3. Okay, and car 4. And then car 5. That's what it states here, okay, for all of the cars, for the linked list, okay. And then we print, and over here you copy this list. Is it? You copy list, so this is another one. Okay, another one. Another one, so what basically it's going to happen is, then you have the first node created, is it? So then within this, you will create another car first. So this is the default. Okay, so that's how you copy the car. And then the next one is going to be car one. Is it? So you are going to create a car one in the second node, and you also connected them together. Is it? So that's how this copying works and continue until you have all of the cars created and they also connected together. Then we can check if this list is the same as the other list. Okay, if it is same, then we output the second one. Okay, second one. And then what next is going to check if it has some specific car. Is it? If it contains. And for this one, if it is, then we are going to do the remove. Okay. So let's take a look at the contains. What is the contains check? Yes. So the contains also check if it has some item that has the same contents. Okay, so just me have another car that has same color, same brand, same everything the same. Okay, but not the same, not that specific car, different car. Okay, so that's what just this mean. Okay. Let's get back. Okay, then we will remove. Is it? And then for a specific car, that is the first car, car one, is it? Then we change the car, is it? So after we remove, after we change, we can check if the second list ever impacted. Okay, we can double check here. Let's run this program. Because we do everything on the first list, not on the second list. Okay, so this is the first list, default, is it? And insert. Oh, I did something wrong. So it's called insert after. Insert after, oh, we need to go back to check. Insert after where? Okay, so insert after one, is it? So insert after, oh, one is a default. Okay, so that's why. Okay, it's always insert after one. So that's previous one I draw, I made something. So this is a default, but default is one, is it? So car one insert here, car one, is it? But then for car two, it's still insert after one. So that's going to be insert like this. So here is car two. So it's always insert after the first car, okay? So that's how we come up with this output, is it? And then for the second one, is it? If we first check, it's exactly the same, is it? And then we do everything on the first list. We remove one, and we also update the first. You can see, is it? It does change for the first one, from default to this new car, new color. And that one is gone, as a car 4 is gone. But we can see the second list. So the second list is still called default. We still have this two, is it? So second list not impacted. because it's not image, so we know this is a deep copy. Okay, so that's so our linked list in this case is a deep copy one. Okay. Okay, so that's regarding this part. And we can also retrieve some car. So here it's get the first car. Then let's take a look, the running result. So that's the first car. That's it. So we did get it. Okay, so that's the to get some specific car. Basically, this serves as indexing. Then let's see. So over here next, we use that iterator do loop. Okay, so in order to use the iterator to do loop, then you need to call the iterator. So you can remember the cursor. So basically, this is that iterator. Okay, it's just like a cursor. That it's pointed to that node. Then we can use the while loop. While if it is next, then you advance to the next. Is that so? You can also using iterator, and in this case, we call it external iterator to do the loop. So you specifically using iterator to do the loop. Okay, and we can also using for each loop. Okay, and if that's the case, then you implicitly using external iterator. And in this case, is you do explicit that using iterator. And here, we never call iterator, but internally it will use iterator. So this is implicit loop for each loop. Okay. Okay, so that's regarding this example. And then what next? Let's take a look. The next one. The next one is the linked list example 3. Okay, so here we have 1, 2, 3. We have 5 files. So we add another one called called Listable. Okay, .java. Okay, and then let's take a look at this example. Okay, how we implement linked list. Okay, so here just try to show we implement linked list in multiple ways. So let's first take a look over here. If you take a look, this listable, over here we define an interface. Okay, so this interface, it extends something. And this collection, basically, it's also an interface. Because it extends, that means it's a sub-interface. Okay, sub-interface. So later on, we will, in the next section, we will learn collection and collections. That's a major component in Java, okay? So over here, we kind of can see what the collection interface is about, okay? And so if you want to use, then you need to import this interface. For iterator, we also need to import. And we also import another one, we call it list iterator, okay? This one, we already discussed. So next, let's take a quick look of this 2 new interface. Okay, let's take a look. The collection, okay, interface. So the first interface is called collection. So it's also a Java official interface. Okay, and its super interface is iterable. So if we draw the hierarchy, then it's iterable and then collection. Okay, collection. And if you recall, previously we also learned, did we kind of see? Yes. If you recall, we learned the queue interface. So basically, queue is also a sub-interface of collection. Okay, collection. And then over here, it also lists all of the class, concrete class. Not here, not all concrete, okay. Anyway, all classes that implement this collection interface. Okay, so let's see someone we learned. So we already learned linked list. So linked list implement this interface, okay. Array list we also learned. It also implement this collection interface. And the stack we also learned, okay. Later on we will learn some other classes, okay, in this list. Oh, so I needed to clear off. And then let's see this interface, okay. So what is this collection, okay. So the collection is an interface. And this interface is a root interface in the collection hierarchy. So later on we will learn, okay. And if you recall in Java, object is it is a root class. And here later on we will also learn, we call some hierarchy called collection hierarchy. Basically it's regarding all sorts of containers. Okay, in this hierarchy, collection is the top one. But we can also say on top of collection, we also have iterable with that interface. So what is a collection and why we define an interface for it? Okay, so collection represents a number of objects. Okay, we also call them elements. Okay, and so that depends that some collection allow duplicate and some don't. And some of the collection going to be ordered and some unordered. Okay, so later on we will see, okay, we will learn all of that, okay. And it said the Java development kit, so JDK, it doesn't provide direct implementation of this interface, okay. But it does provide implementations for some sub-interface like list and set. So later on we will see, okay. So anyway, so it's just regarding a group of objects, etc. And a group of objects, then you need to have some operations on it, etc. So let's see. So that's why over here, because it's an interface, so it has methods, etc. And it has abstract method and default methods, etc. Like over here, it defines the add method. So add method, what does this interface support add method do? It just ensure that this collection contains some specified element. Okay, so you can add. And you can also do add all. And for the add all, now we understand. If you recall previously, we already used this add all method. Is it that add all method? What is the type you're going to add? It's some collection. And this collection, okay, and over here we use that wildcard, is it? And whatever the type, the generic type it is it? And so it can be that, and it's a subtype. So now we understand why we use collection as the type, because then whatever concrete type, so if you have linked list, this will work. If you have array list, it will also work. If we use stack, it will also work, because all of them implements collection. Is it? So that's why this is more generic, more general. Is it? So you can add or some concrete collection class. Why? Because they all implement that interface. Okay, and for this, it also has an abstract method called contains. Okay, and we can take a look. It's abstract method. Is it? It can contain. It also has contains all. Is it? Contains all. Then the type is wildcard collection. Okay, and it also supports equals method, empty iterator, remove or return all size to array. Is it? All sorts of methods. Okay. And let's see, does it have abstract method? It also has some abstract method. By abstract, the string is already implemented. Okay, so that's regarding this collection interface. So another interface that we will say is called list iterator. It's also an interface. It's something related with iterator. It's iterator's sub-interface. Okay, iterator's sub-interface. And iterator basically previously from linked list, we already know basically it's a pointer to a specific node. Is it? So iterators is quite helpful because it allows program to traverse the list. Is it? But previously, what we implemented, this is linked list. This is simply linked list. Is it? So it's one way from beginning to the end. Is it? So you can only travel from first to last. Okay. But a lot of time, we will also see doubly linked. Doubly linked, then it also has a field called previous. So you have the tail, you also have a previous. So it's pointed to the previous one. It allows you also point to the previous node, so that you can do forward traversing. You can also do backward traversing. Okay, you can do in both direction. Okay, both direction. And it also, iterator also allow us to modify, if you recall, as it supports the remove method. As it, even after remove, you can still obtain the iterator's current location, position in the list. Is it not like Because if you just use the definite loop, normally definite loop means for loop, okay, not like even like for each loop, is it? So that's definite loop. While loop is a different story, is it? For definite loop, because it's a definite, so it's fixed number of iterations. Because it's a fixed, just think if you do add or remove, that will break the number of the original collection or container or linked list, etc. So that will cause a problem. But with the iterator, then we don't need to worry that. Okay, so it will take care, it won't break. Okay, and it said this specific list iterator interface, it doesn't have current element. Okay, so its position is between the element that would be returned, okay, by a call to previous. So if you wanted to get the element, then you call the previous and the next. So you can get both the previous and the next. That's what it means. So here it shows. So it's not the specific one, not like the iterator that we learned before, okay? So it's point to the sum between the previous and the next. So here is next, here is that previous going to return, okay? So you use this list iterator because it's supports both forwarding and backward traversing, okay? So that's just some side topic. And then let's get back to our coding. Okay, and over here, we define an interface that's a sub-interface of collection, okay? Then let's see, what did we do? This method, it's still an abstract method because we didn't implement it. So because for the, if you recall, for collection interface, it only supports add an item. Didn't see add at some specific location. That in this case, we wanted to make it have more feature. We wanted to also can add at some specified index position. Then you need to provide this method. Okay, the equals method is an abstract method. The get, the indexing abstract method. And the index all. So that's do search some item and return some index. Okay, and remove. And this remove. This is called what? Called the overloaded method. Because both have the same name, but their parameter signature is different. This is a type. And the return type is also different. Size is also an abstract method. And the iterator method, okay, also abstract. And list iterator is also abstract. Okay, so all of these above are abstract method. So abstract means you didn't implement. But here, we have some method called isEmpty. And it is a default method. If it is default method, then it must be implemented. Okay, implemented, but let's see here. That's very interesting, is it? It called the size method. Size method is not implemented yet. Is it? Then why can you do? Yes, you can still call the unimplemented abstract. That's fine, because then whatever the concrete class that implements this interface, they will take care of the implementation of the size method. Then this default method will use whatever that concrete class's definition. So this is fine, okay? So in default method, you can call abstract method. That's fine, that's allowed, okay? And then let's see for this add all. This is default method. Okay, so what its parameter type is that collection interface. Okay, so that collection interface, then we want to do one by one add. Is it? So we can use that empty function to do check, and we can do for each loop also. Is it? And why we can do this? Because this C is collection. Is it? And the collection supports for each loop. That's why you can do that. And then within, you just call that add. This add is abstract method. That's fine. You can invoke any abstract method. Okay. So we just call the add for the add all here. Okay. And of course, you need to determine if it's empty or not. Okay. If it's a return false, that means whatever you plug in is an empty one. Okay. So that's what the adds all works. Then the contains, same thing. Okay, for the, it's a default one. Let's just call that index of method. And that one is an abstract one, but you can still use it. So in this example, basically we can see this beauty that with the interface and abstract method, not the beauty of default method. The default method is assuming that you design an interface. Is it probably a year ago? So 1 year ago. At that time, you don't have this method. Is it not having at that time? Maybe you don't need. But after 1 year, then based on the feedback, your library, a lot of needs for this contains method. Is it? And if we just add an abstract method definition, then whoever the third party use your library, then they are going to update their software. So that's a lot of work. Is it? So with the default method, then you just add this default method. Okay, and then whatever the third party want to use, they don't need to even update. Is it? They can just go ahead to use this contains method. So it saves a lot of software maintaining work also. Okay. Okay, so and over here, just call that index of. Is it? And anyway, index of is implemented by your concrete class. Okay. And for this add method, it's the same thing. Is that you can call the abstract version of the add method, And the true array method over here, we also implemented. Is it? And what over here is because you're going to return a new array. Is it? So over here, what our purpose is a deep copy of array. So that's why we declare a new array and we call new to create the array. Is it? Then we do the assignment. If we really want to do deep copy, then we should also call the clone. But that depends on T, if T support the cloneable. So that's why over here we didn't do that. Okay, so we shouldn't say this is a real deep copy. No, this is not a real. But regarding array part, it is deep copy because it does create a new memory location for array. Okay, then it return the array. Okay, and for all of the remaining, you do need to do this override because collection. Okay, collection has this method, so that's why you needed to do this. Okay, you still needed to take care of this retain all method. And over here we didn't implement. Okay, and we can leave it as some exercise. Okay, it's a very good exercise. And remove all, contain all, etc. We also have another version of the toArray method. And it's also a default method, okay. Okay, so that's regarding this interface, okay, listable interface. And then let's see our linked list. Then we define another linked list. And this linked list is going to implement our listable interface that we just defined. For this linked list, this is a doubly linked list. For the doubly links, we still define a node. Is it? And the node has two parts now. It has a data, three parts. It has the regular next. We also add this part previous. So basically, a node not just leading from forwarding node to the next node. We also let it connect to its previous node. So that's how they connected together. So here is the next. Is it? And this is the previous. The previous, then point to the previous node. Okay, so this is the previous, it's also point to, is it? So we have two links. So that's why we call it doubly linked list. Okay, doubly linked. And then because of this, then let's see. It's a constructor, you need to take care of the data part. Is it? Because you have two parts connect to the next one, the previous one. Is it? So that's why whenever you create a new node, you need to specify its previous and its next. Okay, so this part we still need to be careful. And for this doubly linked list, then if you just use a single instance variable, that's not going to work, okay? Because you want to traversing from first to last. We also want to traversing reversing order, is it? So that's why the forwarding taken care of by this, basically this is the first node, we call it a header. And the backwarding, then we use the tail. Okay, so tail is the last node. So this is the tail nodes, and it has a one that's point to the previous one. Okay, point to the previous node. So this is back. So we do need a node to remember who is the last node. Okay, and for some special purpose here, we also add a instance variable. We call it count. So count number of nodes. Okay, and I think we run out of time today. So